In this video, we are going to learn the scale cube. But before that, let's understand why scaling is important in microservices. As you know that the main benefits of microservices are independent scale and deployments. So the first step of this benefit, we should clearly identify microservices which parts could be required to independent scale and deploy. Otherwise, it is hard to change the part of the independent scale after decomposing microservices. For that reason, we should be very careful in this decomposition step. Also, this comes with the design principle, which is the decompose services by scalability requirements. Applications are consist of multiple modules or services with different requirements for scaling. For example, here you can see our microservice architecture, and you can see that we have a web application which is a public facing website, and also you can think that we have an administrator website, and these only perform some administrative task into our microservices. So the public site may experience sudden surge in traffic, while the administrator site has a smaller and more predictable load. So it is clear that these two services require different scalability requirements. So now we can deep dive into what is the scale cube. Scaling is widely known with horizontal and vertical scaling, but this is just one dimension of scaling. According to scale cube, there is 3 axes. So the scale cube is comprised of 3 axes. The first one is X axis, the second one is Y axis, and the third one is Z axis. So let me explain one by one. Here you can see the X, Y, and Z. So let me start with the X axis. This is usually referred as a scale out operation, which can be handled with public cloud providers and also Kubernetes, which is the container orchestrators. Mostly the application is running multiple copies on behind of a load balancer. This is a commonly used approach of scaling an application. We also use these x-axis, which is the horizontal duplication scaled by cloning for our application services, which is the stateless services. And the second axis is y-axis. This is the functional decomposition that can be achieved by decoupling our architecture into functions. Microservices in an example for functional decomposition. Y-axis scaling splits the application into multiple different services, and each service is responsible for one or more closely related functions. So when a monolithic application is decomposed into smaller and autonomous deployable units, this approach of scaling can be achieved. Microservices support such a scaling model as they are independent, smaller, fine-grained services with their own database. So we have applied the y-axis decomposition, which is the functional decomposition, when we are learning the microservices decomposition patterns and implementing these patterns into our e-commerce application. So we can say that combining with the X and the Y axis with microservice architecture can give better scalability. And also we have Z axis. Z axis is mostly using for data partitioning. The functions are able to run with a subset of data. So this scaling model is similar to X axis, but the only difference is each service is responsible for only a subset of data. So that means in the X axis we can perform horizontal duplication, but these are the stateless services. But in the Z axis, it is again applying to horizontal duplication, but in the Z axis it has stateful services that we need to perform data partitioning and sharding operations. So we are going to scale our microservice design with both 3 axes. Since we have decomposed the microservices, that means we applied the y-axis scalability, and if we deploy our microservices onto container orchestration tools like Kubernetes, that means we can also apply x-axis scalability. So the only thing left is z-axis. We should cover how to scale databases into our design with using database sharding patterns.